This conference will now be recorded.
Welcome everybody to our MicroChannel Cooler webinar. I know we're still getting a bunch of people coming in. This was by far the most popular of our webinars from an RSVP perspective, so we'll probably give it a couple of minutes. And then I'll introduce myself and my colleague, and we'll get into talking about the exciting world of coolers. So we're really looking forward to that. So bear with us for just a couple of minutes. Remember to, as always, you can use the chat bar to enter any questions you may have during the presentation, during the webinar, whenever. It's possible. What we could do is pause and address your question, or we could wait towards the end and then answer your question that way, but we won't forget about you. See some familiar faces, familiar names. Looks like we got 11 on so far. We'll give it another minute or two. I think we had about 15 or 20 who RSVP'd, so we want to give everybody a chance to see this. All right, just another minute or two, and then we'll get started. Gunman, how's that sound?
Sounds good.
Okay. All right, well, we got 15. Hey, everybody. I'm Jason Greenspan. I'm the sales manager here at Stellar. And the other gentleman you can see a picture of, that's Gunman Ryu. He is our managing director. And Gunman's been with us since, when was it, October?
Oh,
2019?
officially, yes.
And Gunman is our resident expert on microchannel coolers. It's one of the reasons why we actually got into manufacturing coolers. Actually, it was about 4 or 5 years ago. We were at a trade show in Pasadena, and we actually were drawing on the back of a menu a cooler design, and thought that our expertise for bonding copper and ceramic was going to meet the needs of what Gunman wanted, and so started our descent into manufacturing coolers. So really happy to talk about that today. And Gunman's going to be presenting a PowerPoint on coolers and how we manufacture them. And again, any questions, feel free to jump in and throw it in the chat bar, or just unmute yourself, and we'll see if we can address the question just right then. And I'll turn it over to Gunman.
All right. Excuse myself because I was planning to be on site with Jason, but because the northeast area had a lot of snow this week, so I'm stuck in my house down in New Jersey right now. So that's why I'm using the just background is kind of my work area. And all right, so I'm gonna turn off my video. I just wanted you guys to see my face so that I'm a real person. So also you're familiarize my face. All right, I'm gonna turn off my camera and then I'm gonna start sharing my screen. Can everybody hear me okay, at least, Jason?
Yes.
Okay,
Yes.
all right, thank you very much. So, all right, now, can everybody see my screen okay?
Looks good.
Can you guys okay? All right. All right, let's get it started. So, good morning, or good afternoon, or good evening, wherever you are located. So, welcome to Stellar Webinar Wednesday. I think Stellar has started our Webinar Wednesday series to reach out our customers during this COVID-19 pandemic. So it's not possible to travel to customer site. So we wanted to do something different and some virtual. So we kind of find a way to do this webinar series. I believe we have done about 3 to 4 webinar by Jason Greenspan, our sales manager. And I believe so far it's been quite successful. I mean, in meaning of reaching out to customer and explain what Stellar can do. So before I started, okay, again, if you have any question, just because I don't see my screen anymore, I see my slide. So you can just unmute yourself and talk, or you can use a chat box and Jason will collect all the questions and we can address it at the end of the presentation. So far we've been doing this kind of a face-to-face meeting, but today I'm gonna use a presentation. Before I start, well, I'd like to formally introduce myself to you. So as Jason mentioned, my name is Gunmin Ryu. You can see my name on my name tag. Let's put it this way. And I'm a managing director of Stellar Industry. So before I came to Stellar Industry, I've been worked at Coherent and Trump Photonics. Both are industrial laser companies. That's where I'm quite familiar with all type of submount, DBC submount or plated submount, also including microchannel cooler from previous and current position. So for saying that, Stellar Industry has been manufacturing microchannel coolers since 2019 in a high volume, and now we have multiple customers from different industry. So we offer a custom built to print service for copper and DBC microchannel coolers. And it can be sized anywhere from very, very small pieces all the way to 10 centimeter by 10 centimeter. If you're not familiar with those unit, then it's a 4-inch by 4-inch. So, and thickness can vary from anywhere from 1.3 millimeter and all the way to about 10 millimeters. So it's very different size and configuration that we can deal with. And as it's showing it here, we are custom built to print company. So we do not usually own our design. Sometimes we have a few design that we have our own design, but normally we work with customer print to design it and modify it and manufacture it. And also, we can perform simulation based on need, and we are ready for R&D and high volume production for this type of coolers. On the right side, you can kind of see how the simulation can work, and you'll see in a later slide on the simulation. And the second picture on the top is our copper microchannel coolers. And third picture is actually the DBC microchannel cooler, which is isolated microchannel cooler for some industry using those. And some company use a second picture like copper cooler, or some company use third picture, which is a DBC based microchannel cooler. All depends on their need and their design. And the last picture is actually the DBC-based microchannel coolers is fully assembled for pumping application for disc laser. And we are relatively one of the our let's say the advantage is we are a relatively small company. So meaning that we can be quite fast and responsive to R&D prototype built, unlike some big companies. So we are quite flexible in terms of working with the customer, and timeline can be adjusted based on your need. So when you're looking at microchannel cooler, a lot of people are talking about laser industry, which is true. I mean, a lot of our customer is a laser-based company. However, there are many other areas that microchannel cooler can be used. Of course, high power laser industry is one of our main application, but it can also be used anywhere from we need it for heat extraction, such as data center for CPU cooling or high power electronic industry. Normally, they mount their device on a DBC substrate and then mount those DBC substrate onto their heatsink. But Stella Industry can combine all of those together and support customer as an all-in-one solution. So we have DBC on the top, cooling on the bottom, and then you can use it as is so that you can skip the middle assembly process. And also, microchannel cooler can be used in LED. I mean, of course, LED and the laser is a very similar industry. And also, the cooler can be used for concentrated photovoltaic cooling. I think there are a lot of company now. The second picture on here on the top is the concentrated photovoltaic devices. So all the light can be concentrated and then onto solar cell. And then you can imagine how hot it can be. So those are almost boiling temperature. So customer wants to really cool it down effectively because those chips are expensive. So they want to spend more money on cooling and effectively cooling so that they put less devices on solar cell. So there are many areas that MCC can be used. So if you have any of this question or any of this area, working in this area, or any other area that you think microchannel cooler, oh, maybe can be used for our application, and please contact us. And if you need any heat extraction advice for your company, also contact Jason or myself, and we're happy to address that issue or uh, solve your headache. Let's put it this way. Any questions so far for first couple of slides before I going into the manufacturing processes? All right. If not, then I hope some people have a question later on. So you guys just waiting for the moment, right time and right moment to ask questions. So I'll move on to the next slide. So I just put out the some very simple manufacturing process of copper microchannel coolers. As you can see from here, of course, the design discussion will be the first one. We'd start with the customer. And then after some discussion and some simulation that verify it meets our within our capability. Sometimes customer wants really, really tough one. And then some cases, I'm not gonna say never happen. Some case we said, oh, we cannot make those because this is beyond our capability. But those things are very upfront for us so that we both don't waste our time. And of course, we submit the price quotation and then PO is received. That's our clock ticking. So, and then we preparation of copper. So there's a many step involved on preparation of copper part. And then the biggest thing is the bonding of copper. We need to bond those copper together, make coolers. Again, between preparation of copper and bonding of copper, there are many steps involved. I'm not going to go into very detail, but if you become much more curious about those steps, and you can contact Jason or myself, then we can go over it a little bit detail. And after bonding, we look at the bonding inspection. And after inspection, we dice those coolers. And then we make really nice surface so that your device can be mounted. So make sure it's solderable, make sure it's wire bondable and all this. So we put plating. Depends on the application. Some people prefer to electrolytic plating. Some people prefer to electrolysis plating. So we have a capability on both. And after that, and our QC department will take it and a final inspection then ship to customer. So these are just very generic flow of our copper microchannel coolers.
Inman,
Now, yeah.
we also have the capability to not only plate the external portion of the cooler, but also the internal channels if they desire, correct?
Yes. So again, these are the need for the customer. Some customer wants to have an internal channel or microchannel coolers to be plated so that it's a corrosion resistive. Or some customer, they already have a treated water, so they don't need to worry about erosion and corrosion, so they don't need plating inside. So we can either plate it inside or only external only or external and internal. So those are all customers need. So that's very upfront discussion about design, what exactly customer wants and how they want us to manufacture it. Those are all discussed upfront. All right. Now, as I mentioned, the Stellar industry have some capability of simulation. So using multi-physics, so we can do solid mechanics, computational fluid dynamic, heat transfer, and multi-physics. So I just put a few example. It's not a one particular cooler, but it shows what we are capable of doing it. So those two picture in the middle one and the bottom one is showing basically how the water is flowing into the microchannel coolers. So these tools are used in performance prediction of design or hydraulic resistance, cooling performance, so that we can look at the temperature of the surface and all this. Because sometimes a customer has a rough design. Okay, we have a rough design. Can you actually take a look at if this design is achievable of our need? Then we plug those into our simulation tool and we do simulation. And then sometimes we suggest, we have a multiple conference call to suggest some improvement to make our internal channel modified to meet customers' need. And also it can be used for design optimization, as I said, before we even get to the build part. We can do a lot of upfront work to make sure that our simulation is also showing what you need as a customer. We have a lot of experience on those simulation versus experimental result because we are making a lot of coolers for different companies, and we experimentally already verify our simulations result is very, very similar to actual result that we get experimentally. So we have a certain confidence. Of course, these are all depends on customers' need or how accurate that you want, but we have a certain some confidence that hydraulic and heat transfer and those parameters will be very close to in real life part. So that once everything is agreed, then we can move on to the next step, which is actually building. Any question about simulation? All right,
Which
you guys.
program you use? Yeah, which
We
program do you use for that?
we use SolidWorks And then we have a multiple. We also have an in-house program that we have our expert actually built those simulation tools, and mainly we use SolidWorks.
Okay, thank you.
Any other questions? But in a SolidWorks, we have different modules, as you probably know, that we can do multiple. That's why we can do multi-physics or different model, because we have purchased different modules for SolidWorks. All right. So now going into the bonding. So biggest part of our cooler manufacturing is bonding. So in a bonding of cooler, there are about three main technologies different companies are using. So first one is a direct bond copper bonding, which is directly mating the similar and or dissimilar material. The DBC process take advantage of copper oxide eutectic point, where the melting point is slightly lower than pure copper. These are a lot of companies using this technology to, including Stella, using this technology to bond coolers. But also, different company, I know multiple companies also using diffusion bonding. So what it does is you mate copper to copper using high pressure and high temperature, and then it's a solid state diffusion process. You marry those two, and there's a diffusion between the two layer, and it become one piece. So these are also capable of joining similar and also dissimilar, because I people using copper to aluminum as a diffusion bonding or copper to copper. So typically, as I mentioned, is accomplished at elevated temperature with high pressure. And also, I've came across some companies making solder-based bonding. So you can actually deposit certain high temperature solder onto copper, and then using vacuum reflow process to put those layers together. So these are all different technology, and there's always pro and cons to do this. But for Stella Industry is mainly using direct bond copper technology for microchannel cooler. So we are going to the use of first one. We have a furnace, in-house furnace, so we can bond our DBC, our own DBC, as well as our own copper to copper bond. So another cooler manufacturing technology is when you're talking about microchannel, there are a lot of there are layers of copper layers to be need to have appropriate feature inside. So in order to do that, there are multiple different ways, but there are two main methods that we're using. One is chemical etching process, and then the other one is wire electrical discharge machining. So both wire EDM and a chemical etching process has a pro and cons, depending on the application. And then again, these things can be discussed up front with the customer based on your feature size and the feature that you need. So chemical etching process is mainly used for, it's an easy production line, production of fine detail and complex geometry, and also it's very friendly for high volume suitable processes. So, but there's some limitation of feature size because it's a chemical etching process that use the belt. So as you can see from the picture, so there are certain limitation of chemical etching process. On the other hand, wire EDM or EDM process can be used fine detail and very complex uh, geometry and highly repeatable process because you can stack up all the copper layer and the wire EDM all at the same time, but it is expensive process compared to chemical etching because wire EDM process itself is more cost uh, more expensive than the chemical etching process. Also, it has certain limitation of scalability for high volume production because you can stack up only limited number of layers and then it takes some time. So those things are limited on between the we can choose and pick and choose chemical etching process of or YEDM process based on customers need. But again, sometimes wire EDM process is preferable because of certain geometry or vice versa. So once cooler is bonded onto some plate level, then cooler move on to the dicing department. So dicing department, we have a multiple dicing machine. So far we have 4 dicing machine that can be used for dicing, for high precision dicing process. Once it's diced, almost almost I mean, each lot we pick a certain lot or certain coolers and go through the detailed inspection, which you can see from the right side. We have an X-ray slash CT machine in-house. So right next, this picture is X-ray machine. You can imagine just your X-ray. It's very similar to when you broke your arm, you put in an X-ray machine, you take the X-ray image. So those are very similar. You can take it as X-ray, normal X-ray. And then this machine also can be used as a CT machine. So again, those things are same as human. When we broke something, we go to hospital and take CT, and those things are on the bottom picture right here. Those are 3D image of, let's say, 3D X-ray. I'm very simple guy. I always just assume CT is a 3D X-ray. So we can generate this 3D image, so we can actually look at the coolers without any destructing the part, so that we can look at the internal layer, how it get bonded, if there is any void, and all this. However, it takes quite some time to do a very detailed CT scan. So we don't normally do every single part, but at the beginning of R&D phase, we tend to have some part going through X-ray and CT. And X-ray is we do repeating all the production lot going through X-ray, not 100%, but certain number of number of plates or number of cooler going through X-ray machine. But we can discuss those whatever is needed. But again, in the R&D prototype phase, we tend to do a lot of X-ray and CT scan to make sure the parts are built per customer's need. And also, we do have confocal scan. We have access to confocal scanning acoustic microscope. So those things also can be used for detecting any void, any any misbond, and those things can be also used. All right, and then the copper after bonding is not really smooth. So in order to have packaged or your chip or whatever you need to bond on those surface so the surface needs to be machined. So we normally use diamond machining, so diamond cutter. So we have multiple machine accessible for those diamond machining. So diamond machine can do very high precision surface finish, and RA number can be less than a 0.05 micron, and flatness can be better than 1 micron. So we have a multiple machine access, and then also we have a Zygo non-contact optical 3D profiler, so we can evaluate those surface after diamond machining. So if you look at the picture, you can kind of see this is our copper cooler. You can see how nice that top surface looks like. We call it mirror surface. So that is a mirror-like surface. So these machines are used normally on the metal mirror surface. So you can make very, very smooth surface. So when you're looking at yourself after diamond turning, it looks like you're looking at the mirror. So you can see yourself looking at that. So it's very nice actually. If you're looking at it after diamond machine, it looks very cool. So this is one of the favorite things that I like to do, kind of look at it. But also the downside is you can see every imperfection because the diamond is a mirror. So if you look at it, and then you'll see everything. So when everything is now done, cooler is now manufactured, diced, and then all the surface is prepped. Now is a copper. So copper needs to have something on the surface to make so that the customer can put those part on the copper coolers. So what we do is now moving on to the plating line. So Stellar Industries plating line provide a capability to process multiple finish in fully programmed automatic plating line. So thickness can be anywhere from micro-inch for micron, and then we can do electrolytic nickel, gold, and copper. And some customer wants copper, but might not be suitable for copper cooler. But if you want to do it, then we can even plate more. Also, we have access to electrolysis nickel immersion gold. We call it INIC surface. So we can do either way to do it. But there is also pro and cons on certain application for doing electrolysis versus electrolytic. So those things we can discuss it as you need it. So as your company or as your company's application. So then sometimes we're expert on plating of electrolytic and electrolysis. So we can also recommend what you actually need for your application. Depends on what kind of solder you use, and also we can recommend you the different thickness or different metal stack, and based on your solder part. And also, our plated part is all solderable and wire bondability is checked. So we can use lead solder or tin silver copper solder or gold tin solder. We can check those solderability. Also, we can check the wire bondability of gold, aluminum, and some fancy aluminum, copper core aluminum wire, whatever the customer need. We have a capability of checking those before we ship it. Now everything's built. Then now Stella Industry is a part of Trump Group, and through our mother company Trump Photonics, we can also offer some packaging service. So our mother company has a lot of packaging capability. So pick and place die bonding equipment for very high precision bonding, and also they have the vacuum solder, wire bonder, heavy wire bonder, and belt furnace. There's a lot of equipments available. So you can see it, what kind of solder we can do. We can do pre-deposited gold tin. Using our e-beam machine, we can pre-deposit gold tin on your coolers or deposit tin silver copper, either SEC 305, SEC 307, depends on your need. And also other solder can be used. And also wire bonder. We can use gold wire, thick aluminum wire, copper core aluminum wire. We can use any of those. So when you're working with us and buying some coolers or some package or some DBC ceramic, we can also help you to move forward on prototyping packaging. So we'll be able to offer that along with our actual part. So this is quite beneficial because some company does not have access to quote unquote prototype and R&D packaging and assembly service. So we can offer those along with the part that you are actually purchasing from Stella. And after all the parts are built, of course, quality is most important. So Stella is AS9100 and ISO 9001 registered, and then we have quality management system is in place. We have a multiple check and balance precision measuring equipment, and also we can do cleaning process for a certain product. And then we have some product goes to 100% inspection, some product goes to some spot check, depends on the customer's need, and then depends on the agreement before. So, and also we use multiple packing and shipping method. So whatever you need, we can actually support your need. So from start to the end, from start when we are discussing your drawing all the way to the quality control, we are fully vertically integrated company, and then we can offer a lot of things. I mean, this seminar or webinar is for microchannel cooler, but if there's any other need for the DBC, or if you miss any of the webinar before, then you can actually either email or there is a LinkedIn link for all those webinars. So you're more than happy to listen those, and we are uploading this video as well to our LinkedIn and YouTube channel, so you can actually watch it again and watch this, look at this slide again from through video recording. And if you have any question, feel free to contact us anytime. Jason never sleeps, so if you're located in Europe, Asia, East Coast, West Coast, wherever you're located, just shoot him an email, then he will answer it within very, very short period of time. And also we have a multiple representative across the US and Europe. And if you're curious about it, and then also contact Jason, then he will be the point of contact for all you need for microchannel cooler or any part that you need from Stella Industry. All right, I think I've talked a lot without any having any questions. So now, okay, so I'm gonna I'll just leave my slide here because in case the somebody have a question that I can go back. So I'm gonna ask audience or Jason if there was any questions.
It looks like there was a question that came in a few minutes ago. Can the inner layers have islanded copper segments, or does each layer need to be a single continuous body? Do you mean an actual isolated individual piece of copper in one of the layers, Nick?
What I mean is basically, you know, I don't know the process for how you build the individual layers, but if you imagine you were extruding something like in a solid body, you could build a layer that sort of had arbitrary features. But what I'm asking is, does it have to be more like a spray paint stencil where all of the features have to be continuous, right? Like, does it have to be something that's solid before you lay it down and bond it? Does that make sense?
So for example, if I'm understand correctly, so so if can you see my mouse by the way?
Yes, I can.
Yes. So if you look at this fin, we call it fin, is connected to the front.
Mm-hmm.
So what you're asking is this: if imagine this fin is somewhere in the middle of this empty area, can it exist on that area only? Is
Right.
that your question?
Yes, exactly.
Unfortunately, because we need to have something supporting from the side or somewhere, so island feature might not be suitable for it. But we can actually
Okay.
build from supporting from the bottom layer and then like make it filler type. So that can be possible. But like really standalone, nothing connected to anywhere is not possible to build it.
Okay. I suspected that, so
Mhm.
that kind of confirms my
Yeah,
understanding.
but as long as
Thank
you
you.
have something to connecting to, then any feature can be. I mean, we can. It depends on what feature size and what geometry it is, but we can discuss those. But anything is connecting to the any of those body can be manufacturable.
Okay. Got it.
Okay. Any other questions from audience or Jason? You have any?
I was curious. One of the first pictures you show has the cooler built up.
This one.
Yeah. Would we be willing to offer the full assembly services like this to our customers?
Yes, because as I mentioned at the end of the assembly slide, so in the bottom right there, so these are the one of the actual product our customer is using. So this cooler is provided by Stella, and then the whole these things manufactured at our customer site. But these are laser diode is bonded onto the cooler and then get wire bonded onto this end contact piece. So it's a diode, the P contact and N contact. So if customer need to have a certain prototyping, but using our cooler or DVC, yes, we are willing to support those packaging and assembly service. And then of course there will be some discussion about the how we're doing it, all this, but we definitely are willing to do those support through our manufacturing line.
And my other question about that picture, again, how many wire bonds is that shown?
This one is about 1,300 gold wires.
And the width of that part is about half an inch, correct?
10 millimeters, so 1 centimeter. So this wire bond is actually 0.9 centimeters. So it's really packed. But you
Yeah.
imagine, I mean, people can say, oh yeah, 1,300 wires, but these wire bonder is like really super fast. Maybe you guys have seen some of those wire bonding for CPU chip, and then it's a long wire and slow. But certain wire bonder is really fast, so it only takes maybe a minute or so to finish all 1,300 wire bonds.
Is that wire bonding a capability that you have?
Yes.
Ah,
So we can do gold wire, copper wire, aluminum wire, and then these days companies are using fancy like combination hybrid wire, which is copper is inside and aluminum is outside as a cladding. So that's called copper core aluminum. So those are very similar to aluminum wire, but have better thermal and electrical conductivity. So that's why people start using copper core aluminum wire.
A question came in from Jacob about how large and small of a form factor can we achieve. I think that Gunman had mentioned earlier in the presentation, the largest form factor we're doing right now is about a 4-inch square.
Yes.
And what do you think, Gunman's the smallest we could do?
Smallest we have done so far is about centimeter by 3 centimeter. So what is that? The in inch? Help me, Jason. Here.
Let's see.
Yeah, I'm sorry. I'm sometimes going back to inch and the millimeters, but these are all customer designs, so I go by millimeters here.
So
So
about 400 mils by
yeah.
about, and what did you say? So you said 10 centimeters by?
No, 1 centimeter by 3 centimeter. That's the smallest that we have done. However, we have designed that 1 centimeter by 1 centimeter. But now it is microchannel cooler, just so that you need some kind of inlet and outlet. So microchannel cooler itself is you use liquid going through this cooling layer to cool down the material, cool down the surface. So it depends on we can make very small, but now the effectiveness of cooling will not be great if you make it too small. Then everything is so small that its hydraulic resistance will be bigger, and then you have a pressure drop across those cooler will be higher. So you will need quite a challenging in terms of the chillers or the pump that you requires. So those
If,
are the challenge.
if a customer came to us and said, hey, I have this chip, it's producing this much heat, I really need to dissipate it, our design guys could work with them to come up with a concept, correct?
Absolutely. So one of the customers now doing, they have a certain, let's say, criteria. So they're using their original design right now at the DBC. And then what we like to do, what they like to do is they have all-in-one service, basically all-in-one package. So, but they have a certain restriction of, top surface temperature needs to be, let's say, 50 degree plus minus 3 degrees. Then we can actually design that cooler's internal channel to meet their top surface temperature requirement. Also, again, it is very important to have how much hydraulic resistance and pressure drop they require, and what kind of water flow they require. So all this requirement can be discussed, and we can actually design the cooler just for customers.
Yep.
So, but again, we do not own usually custom cooler design, but we have a capability of helping you as a manufacturer, helping you to design something is suitable for your company.
We had another question come in. Can we say something, what we do to prevent black spotting during nickel and gold plating?
So those are normally electrolysis plating. So that's why I was mentioning it depends on what kind of application. So we normally control phosphorus content so that the is suitable for black pad or black spot. I think that's probably the same one that the customer is mentioning it. So there is a certain technique that playing with the phosphorus contents on the electrolysis nickel gold to prevent those black spot or black pad effect. And also, if you're so critical about those, then we also sometimes recommend to go with electrolytic. So some of our customers have concern about those, so that they move on to electrolytic nickel gold instead of electrolysis.
We had talked in the past about Stellar releasing a standard off-the-shelf type cooler. Is that something we can talk to a little bit?
Yes. So right now, this is a good slide that right now you're looking at the second picture right here. second from the top, those are copper coolers. And then the Stella is now making those copper cooler as off-the-shelf part. So it'll be, I don't know, I think within a month or so, it'll be available to customers for sampling purpose. And if they want to use those cooler for any sampling, we can actually ship those and then a small sample base. And also you can actually purchase those through our sales line. So this will be off the shelf part.
That's exciting.
Mm-hmm. Any other question from anyone? Anyone? Anybody? So everybody's understands, or is it the that you don't know what to ask yet?
I think everybody is thinking to themselves, how can I incorporate coolers into my products so that we can, start buying them from Stellar?
That's exactly what we want you guys to think about it, because again, these are the application. There's a lot of people are microchannel cooler is, I mean, again, mainly used for a lot of optoelectronics industry, lasers, LED, and maybe some concentrated photovoltaic. However, there is a tremendous, I know some of you might have built your own computer before or assemble your own computer for gaming, or your kids are doing it now. And then there's all sorts of cooling pipe that your kids or you did to cooling the computers so that your computer is performing fast or your CPU performing fast. So those are also one of the applications that we are going after, high performance computing. When you have high performance computing, that CPU or your board gets really hot. And then, as you know, once it get hot, the performance degrade. So the people now putting those active cooling mechanism on the bottom of those chip or board so that they can cool those entire chip or board very effectively. Same as the high power electronics, and same as your application going up somewhere in desert or somewhere that you have application, that if you use any DBC or any packaging and then you are having a headache on cooling, but you know in your system you are using water or some kind of cooling liquid, then there's a good chance that Stella can make all-in-one package so that you can cool it effectively, those chip or board or whatever you need to cool it, or lenses or something that you can make it. Then we can design it around it so that we can have you can have a good heat extraction from your device or from your parts. All right.
So basically that means, Gundan, we can take the substrate, the bonding of the substrate to a heat sink and the heat sink, and combine them all into one cooling module. So the customer doesn't have to worry about 3 items in their supply chain. They only have to worry about one.
Yes,
To worry about yield loss of assembly of these devices, right?
That's exactly what I meant by power electronics. So those chips or power transistor is mounted on the DBC substrate, and those DBC substrate with power transistor is mounted onto something to get it cooled. But we can integrate all those into one device, and then now of course, you still need to mount those power transistors onto DBC surface. However, those DVC surface already integrated for the cooling devices, so that you can put, it can be water, it can be ethanol based, it can be some chemical. People use a different method to cooling as a coolant. So, and then some people use treated water, some people use DI water, and all sorts of water you can use for those devices cooling.
Mark asked if we had any pictures of what we are describing. Mark, can you elaborate as to what you mean? Do you mean the assembly process or assembled device?
Yeah, an assembled device, what it looks like. Like, can you attach this to a microprocessor?
So this is a fully assembled devices, but this is not exactly microprocessor. This is a laser diode. So these are this top surface is DBC substrate basically, and then cooling channel is in the middle layer. All this, and then you can imagine this as the fully integrated all-in-one package. And then you can imagine this laser bar now it's became your microprocessor or power electronics devices onto DBC surface using your solder, either SEX 305 or SEX 307, or some customer use a gold tin solder to mount those devices. And then you can mount this whole DVC onto your manifold, which has a water inlet and outlet. Because on the back of this has the you can see from this picture there's an inlet and an outlet. So you put O-rings around it and then screw it down to those manifolds so the water can just go in and out of those microchannel coolers.
Okay, thank you very much.
Okay. There was a question on to some chat box, I believe. So I saw something pop
To
up.
piggyback on Mark's question, the request was, do we have any examples of power electronics integration?
We don't have a picture here, but we can definitely provide that information to Mark. Do you also want that?
Yes, that would be great.
Okay, so we'll provide that information how we can integrate those because those are new field that we're exploring because we saw a lot of need for power electronics companies to making those all-in-one package, and some company was quite excited to have those because now, as Jason mentioned, there's a multiple solder interfaces that you have to deal with it, and then there's first interface, second interface, and different solder. More step you adding, more yield loss you have to deal with it, more vendor you have to deal with it, and all these things, so that there's quite an interest movement on power electronics on the microchannel coolers these days.
Thanks again.
Okay. And I mean, these things are, I mean, extremely nice, so that if the customer wants to have a certain geometry, okay, I want this geometry, I want this geometry, and you don't need to identify any of the internal cooling channel. You leave it up to us. You can define, I want the top temperature to be XX degree, and I have a heat source of X, like let's say 1,000 watt of heat source mounted on top surface of the DBC, and then I can use this type of water. I can have this type of pressure drop on our cooler, and what else? And then can you design something for us? And then because we love to have R&D project, because again, we can start from R&D prototyping and then get to the high volume. So that's what we do. We start from this simulation. Again, these things are built from scratch basically, both of them. So we can actually provide all this information to the customers for a prototype phase. Any question from anybody else?
Yes, I have one more question. What's the typical turnaround time for, say, your most popular design?
Oh, these coolers or this type of coolers?
Yes, for these types of coolers.
This type of cooler is normally in a high volume case, we normally ask for about roughly 8 weeks because the volume. But in the R&D phase, we can expedite those obviously. So because this copper cooler is faster because we have a certain reduced step for those copper cooler, and this DBC-based channel microchannel coolers is a little bit longer, about 1 to 2 weeks longer. But these are about 8 weeks. We can make it probably squeeze to 6 weeks on these type of coolers. But if it's already pre-exist design, then we can make it faster because we don't need to discuss the design back and forth because we already know the design escape. We can build those.
Yeah, I wanted to throw that in there, Goodman. It certainly, the clock starts ticking from when we finalize that design for you.
Mm-hmm.
Okay, great. Thank you.
Any other questions?
All right. If not,
I see people clicking off of mute, and then I